Have you ever wondered if the number 3 exists in the same way this chair you're sitting on exists? It's a wild thought, right? Have you ever wondered if the number 3 exists in the same way this chair you're sitting on exists? It's a wild thought, right? We can't touch it, see it, or smell it. So, is math just a clever game we humans invented? A tool we created to make sense of the world? Or is it something more profound? A hidden language of the universe that we aren't touch it, see it, or smell it? Or is it something more profound? A hidden language of the universe that we are slowly discovering? Welcome to the ultimate intellectual boss battle. Is math invented or discovered? Let's start with team invention. This idea, known as formalism or anti-realism, suggests that mathematics is a product of the human mind. Think of slowly discovering? Welcome to the ultimate intellectual boss battle. Is math invented or discovered? Think of it like chess. We invented the rules, the pieces, the board. The statement, checkmate, is true only within the rules of chess. Similarly, mathematical truths, like 2 + 2 = 4, are true only within the system of axioms and rules we've created. The philosopher Ludwig Wittgenstein was a major like chess. We invented the rules, the pieces, the board. The statement, checkmate, is true only within the rules of chess. The philosopher Ludwig Wittgenstein was a major proponent of this view. He argued that math is a language game, a set of rules we follow. So, when we do math, we're not discovering some deep cosmic truth. We're just getting really good at playing by the rules we made up. He argued that math is a language game, a set of rules we follow. It's a powerful and practical view. After all, we define what a number is, what addition means. Without our definitions, do these concepts even exist? But hold on, because team discovery has a powerful counter-argument. This view, known as Platonism or realism, proposes that mathematical entities, numbers, shapes, theorems, exist independently of us. After all, we define what a number is, what addition means. Without our definitions, do these concepts even exist? This view, known as Platonism or realism, proposes that mathematical entities, numbers, shapes, theorems, exist independently of us. They live in a kind of abstract realm, a world of perfect forms. We don't invent them. We find them. Think about it. If math is just an invention, why is it so ridiculously effective at describing the physical universe? The physicist Eugene Wigner called this the unreasonable effectiveness of mathematics in the natural sciences. Let's level up this thought. The orbit of Neptune wasn't just observed, it was predicted using mathematics. In the 1840s, astronomers noticed Uranus was wobbling in its orbit, not following the path Newton's laws predicted. Two mathematicians, Urbain Le Verrier and John Couch Adams, independently crunched the numbers. They proposed that an unseen planet's gravity was pulling on Uranus. They even calculated where this mystery planet should be. Telescopes were pointed to that exact spot, and boom, there was Neptune. How could a mere human invention predict the existence of a massive planet billions of miles away? It's the natural sciences. Let's level up this thought. It is like writing a fantasy novel and then discovering one of your fictional characters is real and living down the street. It seems to suggest that the structure of the universe is fundamentally mathematical. Let's take this further into the quantum realm. The equations of quantum mechanics, developed in the early 20th century, are like writing a fantasy novel and then discovering one of your fictional characters is real and living down the street. It seems to suggest that the structure of the universe is fundamentally mathematical. Yet these equations are the bedrock of modern technology. The smartphone in your pocket, the GPS that guides you, the medical imaging that saves lives. They all work because these abstract mathematical formulas accurately describe the behavior of subatomic particles. A 2013 study published in the Proceedings of the National Academy of Sciences even showed how abstract group theory, a branch of math, perfectly describes the symmetries found in quantum systems. It's as if the universe is playing by a mathematical rulebook we just happen to stumble upon. Here's another mind-bender for you. Consider the Mandelbrot set. It's an infinitely complex and beautiful fractal generated by a very simple equation. Z becomes z² plus c. Before computers could visualize it in the 1980s, did this intricate shape not exist? Or was it always there, waiting in the realm of mathematical possibility for the Mandelbrot set? Most mathematicians who work with these structures feel like they are explorers, not inventors. They talk about discovering beautiful theorems and elegant proofs, not creating them from scratch. It's a feeling of uncovering something that was already true. But what if there's a middle ground? Someone with the right tools to come and see it. But what if there's a middle ground, a third player in this game? Some philosophers and cognitive scientists suggest a kind of embodied cognition. This idea is that our mathematical concepts aren't just arbitrary inventions, nor are they abstract entities from another realm. Instead, they are grounded in our physical experiences of the world. The concept of more comes from having more food or third player in this game. Some philosophers and cognitive scientists suggest a kind of embodied cognition. The idea of a line comes from seeing horizons or straight sticks. Our brains, shaped by evolution in a physical world, developed the capacity to form these basic mathematical intuitions. Then, through language and culture, we built upon these foundational ideas to create the complex structure of modern mathematics. A fascinating 2017 study in Science Advances looked at an indigenous group in the Amazon called the Munduruku. Their language has very few words for numbers, yet they could still approximate and compare quantities. This suggests a core, innate number sense that might be part of our biological heritage. So, maybe the basic blueprints for math are hardwired into our brains by evolution because they were useful for survival. Then, our creative, inventive minds took those blueprints and built incredible skyscrapers of abstract thought. So where does that leave us? Is math a tool we forged, a map we discovered, or a language that grew from our interaction with the world? Then, our creative, inventive minds took those blueprints and built incredible skyscrapers of abstract thought. This debate is far from over. What do you think? Are you on Team Invention, convinced it's our greatest mental creation? Or are you on Team Discovery, believing we're uncovering the universe's source code? Or does the middle path, the idea of our embodied experience, make the most sense to you? This isn't just an abstract philosophical game. How we answer this question shapes how we teach, learn, and feel about math. Perhaps the beauty isn't in finding a definitive answer, but in the profound question itself. Is it a rigid set of rules to be memorized, or a mysterious landscape to be explored? It forces us to confront the nature of reality, the power of the human mind, and our place in the cosmos. The fact that we can even ask this question is, in itself, pretty amazing. Let me know your thoughts in the comments below. I'm genuinely curious to see where you all stand in this great debate, and if you enjoyed the nature of reality, the power of the human mind, and our place in the cosmos. And if you enjoyed this journey into the mysteries of math, make sure to hit that like button and subscribe for more deep dives into the biggest questions in science and philosophy. Thanks for watching.